Welcome to Medical Myths, Legends, and Fairy Tales. I'm your host, Dr. Alan Christensen. Look, you know that between the latest online fads and the crazy media headlines, it's easier than ever to get confused about your health. And you and I just want to feel better and live longer. We want to know what works. And we can't wait for further studies. We need to make decisions today based on the best evidence we've got. Well, that's exactly what this show is here for. So let's get to it.
Hi there, this is Dr. Linda Kashaba from Integrative Health. Would you like some help with your thyroid? We would absolutely love to help you out. And guess what? We can even do remote care. Please call us today at 480-657-0003 to set up your first appointment. If you mention code podcast20, you will get 20% off from your first visit. That phone number again is 480-657-0003, and the code is podcast20. Can't wait to meet you.
Hey, Dr. C here with you, and welcome to another legend of medical myths, legends, and fairy tales. So, you know to avoid the foods on the Dirty Dozen list, right? And you know it's updated every year. And you know that if you can't get organic, the Clean 15 are safe things to fall back on. Well, last year I would have told you just that. But somewhere several months ago, I thought to look at the methodology behind those lists and how they're derived and really the logic that goes into making them. And I got to tell you, I was left pretty disappointed. And after doing some more reading, I found that I was far from alone, that pretty much every other food scientist, toxicologist, anyone who knows about these issues has come to the same conclusions, that this is not how you would actually find out which foods are safe and which ones are not. So I wanted to talk through some in really good detail, and I wanted to pull in a food scientist and who has a knowledge about the toxicology of these factors. So I got a hold of Steve Savage, Dr. Steve Savage. He's written some good detailed discussions about this, and we had a great conversation about it. He's a PhD in the field of plant pathology from UC Davis. He's been active in this world for 40 years, and he's been communicating these issues to the public, contributing to Forbes, and also through his own podcast called Pop Agriculture. So he and I went deep into this, and pretty amazing. We found out there are some types of perhaps persistent pollutants that are still in the food supply that, if anything, are actually higher in organic foods. And you don't hear about this stuff in the Dirty Dozen. So please enjoy my discussion with Steve Savage. Hey, Dr. C here with you. I am really excited about this discussion. Steve's here with me now, and we're going to talk through this a bit. So let's jump on in. So Steve, welcome to the podcast.
Thank you.
So I've talked for quite a while about the importance of good food. And, honestly, I just went along with what a lot of my peers mentioned in terms of avoiding high pesticide produce. But somewhere in the last few months, I started coming across data about how the Dirty Dozen actually makes their lists.
Right.
And quickly I realized, wow, there was a much deeper story. So let's talk through this. Tell me what you've learned.
Well, it's interesting. The Dirty Dozen list is supposed to be based on this public data set that's done by the USDA every year called the Pesticide Data Program.
And publicly available stuff, yeah.
Yeah, and actually it's this great example of a transparent government activity and data, and it's really kind of an outstanding example of that. And what that thing was originally designed to do was to sort of check on the system and see if it's working. So the EPA has the job of deciding, all right, what pesticides are or are not approved, and also then how they should be used to make sure that it's safe by the time it gets to the consumer. So what's the maximum amount that could ever be used? What's the highest rate at any one time? How long before the harvest is the last time you can use it? And that's all designed around trying to make sure that by the time the food gets to the consumer, any residues are not just safe, but like really safe. And so what the EPA does is to set this thing called a tolerance to do that.
Mm-hmm. So this is a good point I want to go deep into because, we all know that there's things that are harmful, but the dosage always matters. There's no substance that's harmful at every possible
No,
dose. There's nothing that's safe at every possible dose.
exactly. Yeah, that's very true. And so fortunately, the science of deciding, well, how much is too much, and that varies dramatically by chemical. Fortunately, that science is really advanced over the last several decades. And so the system that we have is designed to try to make sure that that's working well. And so this program by the USDA every year basically pulls 10,000 samples or so out of the food supply. They kind of pick a different list of foods, mostly fruits and vegetables, every year to check. And they look to say, the question they're asking is the system working? Are the residues down at levels that aren't a problem? And every year, basically, that's what it says. It says, wow, this is going really well. Not only are they below the threshold level called the tolerance, most of them are way below.
So some of your data I saw talked about this in terms of body weight comparison. So for example, if spinach were a problem that could be quantified in terms of, like, say, if I'm a 160-pound guy, how many multiples of my body weight in spinach could I eat before this exposure was an issue?
Right. And it's usually some ridiculous amount, right?
So if I were to eat like 100 times my body weight, I might need to start worrying.
Yeah. And frankly, if you ate 100 times your body weight in spinach, that's pesticide residues would probably be the least of your problem. Well, because, spinach is actually a good example to bring up because it, like most plants, actually makes some of its own pesticide.
Mm-hmm.
It makes the oxalic acid that kind of gives you the distinctive taste, one of the distinctive tastes of spinach. Well, actually, I think that would get to you long before a residue of pesticide that was on it.
I'm glad you mentioned that. I pulled up a study from Dr. Bruce Ames.
Yeah.
And this was from 1990. Yeah. And he argued that somewhere around 99.99% of our pesticide exposure are from the things like you mentioned, the ones that are innately present in the plants.
They are. And as we all know, there are totally poisonous plants, right? That, by some of the things that are made in them. But actually, some of the things that plants make to defend themselves, we actually end up developing a taste for it. So one of those would be caffeine. To a coffee plant, that's to protect it from insects. To a pepper plant, capsaicin is there to protect it from insects. And we've decided we like that trigeminal nerve stimulant. So
I'm a fan.
Yeah. So that's what the data set actually shows. And so that's why it's so particularly frustrating that somebody takes that data set and then manipulates it in such a way, basically to sell organic food through fear.
So explain to us the process they used for pulling that data set, taking that data, and how they arrived at the dirty dozen from that.
Yeah. So the data set, and you can get the entire data set as long as you're willing to deal with a 2 million row table. And yeah, it's not a lot of fun. And so it lists everything that was tested and whether or not it found it, and if it found it, how much. And chemists can find these incredibly small amounts of things. So, out of the 2 million rows, there are, I forget, 160,000 or something where something was detected. And those levels that were detected can be compared to those tolerances and say, okay, how is it relative to the tolerance? But what the environmental working group does is to ignore that tolerance. And so to them, pretty much a detection is a detection. And so if you find something at a part per billion and something at a part per thousand, they would treat those two numbers essentially the same.
So if there were some differences of exposure concerns, it wouldn't register on that.
No, it really just, essentially what it comes down to is how good chemists are at doing what they do. Having these super sensitive testing methods. And
You know, it made me think about like forensic science. You know, they can check these most minuscule quantities of things in a crime scene, but it's not that that amount was a relevant amount, but there's this tiny trace can be detected.
yeah, and to me, the fact that the government is transparent and says, look, I did find this, but it's at this incredibly low level, that's more honest than if they just said, well, we'll only tell you if we find something that's a problem. I mean, they might legitimately want to do it that way, but I think they're being more transparent by showing you the little tiny number.
You know, and I could see some listeners thinking, okay, well, if there's a little bit there, why wouldn't I just buy organic to be safe?
And there's there's two main reasons that that isn't actually your option. The first one is most people think organic means that no pesticides are used, right?
Yeah.
That isn't true. That's strictly not true. And you can go on the USDA's website for the organic program. You can look at the website for OMRI, which is an organization that approves which pesticides or which chemicals of any type can or can't be used on organic. And there's a huge list of things that can be used. And so it isn't that the organic grower doesn't have pest problems, and it isn't that they can't try to do something about it. It's just they're limited to the list of things that are considered natural by this committee. Okay. And the problem with that, as you were pointing out, is that the fact that the pesticide is natural is actually not necessarily an indicator of safety. Every one of those products has to go through the same analysis by EPA to decide if it's safe. And there are certain natural products that were used in the past that are no longer allowed by the EPA because they're not safe enough.
You know, I'm looking at one of your articles here about chemicals detected in organic samples in the 2017 PDP, and a lot of these are things that are, you know, obscure terms, but DDT. So I'm assuming that there are some non-natural pesticides that are also measurable and showing up on organic samples.
Yeah, well, now in the case of DDT, that's actually kind of just a historical thing they're following.
Okay.
So DDT was, you know, once considered this amazing thing, and it really was a huge help with human spread diseases. But that was before people sort of knew that there are certain chemicals that persist for a really long time in the food, you know, in the soil or in the environment, and they actually bioaccumulate in the food system. And, you know, that's what the EPA was originally designed around once people realized, oh, we better figure these things out. And so since then, things like DDT have never been approved or allowed. But the residues of those are still fading away slowly. So yes, whether something's organic or not, you know, it can still have those traces that go back in history. But the other thing is that in the organic samples, they not infrequently find a residue of a pesticide that actually is not approved for organic. And I don't think, I'm pretty sure that really doesn't represent, you know, organic farmers cheating on the rules. I mean, that could happen, but I don't think that's what this is about because, again, the levels are really, really low. It could be something like a little dust from a dusty road between two fields drifted over, you know, and that kind of really small exposure could be detected. Or maybe the apples are picked and put in some bins that have previously been used in the conventional part of the orchard, and you know, maybe they can pick up a tiny amount of something.
Wow.
But anyway, if somebody thinks, oh, if I buy organic, I'm getting nothing, no, they're not. And then the other twist on that is when the USDA does that testing, they actually don't look for some of the things that are used on organic. First of all, partly because they're probably not something to worry about anyway, and actually, practically speaking, because it would require a whole different kind of testing. So, for instance, probably the pivotal fungicide for use in organic is compounds based on copper, things like copper sulfate, copper hydroxide. And technically those get called natural because that is a naturally occurring element somewhere. Well, those are actually used at quite high rates if they're used on an organic crop. But USDA doesn't look for those. If they looked for that, if they looked for residues of sulfur or lime sulfur or paraffinic oils, basically mineral oil, if they were looking for that, they would find it for sure. Again, it would probably fall into that same category of still nothing to worry about.
Yeah. And then also the things that are within the plants themselves, like I mentioned before, are not part of the process.
No. Well, and yeah, again, through plant breeding through the centuries, we've tried to avoid the worst of those natural materials. But for instance, you really wouldn't want to eat a green potato. You wouldn't want to eat the sprouts that might start coming out of your potato when it's been in your cupboard too long. You know how that happens? And there are really high levels of these plant-made insecticides called glycosylinates that could actually even make you sick, you know. But obviously, yes, nobody's out looking for those. But fortunately, it's rarely an issue within our food supply.
Well, and this is a tricky thing psychologically. It seems like if something could be dangerous in some context, that it must always be dangerous in every context. You know, there are many who are quite concerned about the ingestion of nightshade plants for reasons like that. Even though the data is strong that there's a range in toxicity. The dosage matters, and some amounts are dangerous, some amounts are not. And there's even many circumstances where the tiny amounts of toxic things may even be helpful.
Yeah, I think that's true. And, you know, have you read the book by Jared Diamond, Guns, Germs, and Steel?
Oh, for sure.
Yeah.
The book and the movie, the phenomenal story.
Well, and the thing that impressed him when he had contact with that, you know, native society, I think it was somewhere in Indonesia, Papua New Guinea, something like that.
Papua New Guinea. Yep.
Yeah. And what impressed him was the sort of oral knowledge base that society had about which plants were dangerous, which plants were good for eating, which plants were good for medicine. You know, people have understood that there's all kinds of interesting things in plants long before they knew what chemicals were.
It's important stuff to figure out.
Yeah, it is.
So the other thought about that is we've got the dirty dozen, we've got the clean 15. And in both ways, they're just not really correlating with one's possible level of exposure of these pesticides, that they're just not accurate gauges of that.
No, they're not. I mean, it's just misleading. But I think, you know, in this modern age of having to sift through all the information out there, one of the things that people always tell you is follow the money, right? And so look at who supports that group called the Environmental Working Group. And this is on their website. They don't try to hide this. And basically, it's big organic companies. And what's interesting, with one exception, they're not organic companies that are in the produce business. They're mostly dairy and other things like that. And so I, you know, being a little suspicious, I think their real goal is just to get people to say, gee, I'm afraid in general I should always buy organic, even though you know, that isn't even something that these testing things are done about. That's
wild. I wasn't aware of that. I was aware of it being some organic groups, but not even those that would directly benefit. But that makes sense as far as consumers preferring organic in general.
Yeah. Well, and the really sad part of that, and there are documented studies on it, particularly with low income populations.
Yeah.
Their take home message from reading this whole Dirty Dozen thing is, well, fruit and vegetables are dangerous if you don't buy organic. I can't afford organic, so I just won't eat fruits and vegetables. And as you know,
Yeah.
that's probably the worst decision you could make.
I've seen a study, probably the one you're referencing, and that was really shocking. It's always what matters is, what's the outcome, and how do things affect people's behavior? Is it more conducive to improving their health? And yeah, the data about the benefits of produce are huge. And I'll tell people about that often, that we have so many studies showing the benefits of produce in terms of cancer risks or chronic disease, cardiovascular disease, diabetes. And I'm not aware of any studies that made distinctions on commercial or organic. These people just ate more produce and were healthier from it.
Right. And I think probably to protect themselves, at some level, EWG comes out at some point in all their stuff and says, oh, but you should still eat lots of fruits and vegetables. But every health expert, nutritionist, whatever, would tell you the proportion of American society that doesn't eat the recommended amount is really large. So the last thing we need is anybody, of any income level to be scared about that.
And I guess a point to talk about too is just the precautionary principle. It seems intuitive to people that, something must be bad. And in toxicology, do you want to like the NOEL? Can you mention the NOEL concept?
The no effect level?
Yeah.
Yeah. When a new synthetic chemical is going to be approved for some use, whether it's, as a pesticide on food or food additive or something, any kind of thing, there's usually some agency that requires this huge data set, all kinds of expensive toxicology studies, chronic toxicity, reproductive toxicity analysis. And to actually do this for some new chemical would cost hundreds of millions of dollars, like $300 million, something in that kind of range. And then the agency, frequently like the USDA or FDA, looks through all of that data, finds sort of the lowest dose that causes any kind of issue, and use that to calculate the no effect level. So when they come up with that, they've looked at sort of every which way that you can look at toxicity. I mean, we as regular people tend to think, oh, toxicity, that's just poisons. That's, acute toxicity. How much can you eat in the short term? But there's all these other things about, well, what about a really low level that you eat throughout your whole life? What's the no effect level there? And that's not a perfect system, because obviously we don't do those experiments on humans. That would be unethical. It's just, a lot of it's done with, animal models, rats being the big main one. But yeah, that there's a lot of work that goes into defining that. And that no effect level is very much part of what the EPA would use to find that tolerance. That again, the tolerance is going to be focused on what's the one toxicity issue that is of the greatest possible concern, and let's focus on that one.
So which thing would show up at the lowest levels? And then oftentimes the exposure thresholds that are set are what magnitudes of order away from that?
Yeah. The tolerances are conventionally set at about 100 times lower than. There's a couple of different terms that are out there. You'd have to get, a hardcore toxicologist to go through the difference. But the no effect level is something that's in the testing and finding some concentration in a specific test, where there's another number called the ADL, adjusted dose level, which is set more to what about something that you eat or are exposed to frequently and over time, so all that kind of stuff. Yeah.
So you mentioned a bit about DDT, biopersisting. How would you describe the arc of the types of pesticides used in agriculture over the last several decades? I mean, how, are we making some progress, or what's happening?
Oh, yeah. I mean, I would say the EPA is set up in 1970, right? I would say by the mid 70s, the things that would be like DDT that are very persistent in the environment, the ones that already existed, those were removed. Tests were set up to look at that. They look at the half-life. They call it the half-life of the chemical. You know, how long in the soil or any place else, how long does it take for it to break down into, you know, harmless components, you know, basically to recycle the chemicals that are in it. So I wouldn't say that anything since sometime in the 70s that had the potential to be a long-term contaminant has ever been approved. And then there's a thing called a re-registration process, and everything that ever has been approved gets looked at again after a few years, just say with our, you know, new understanding of toxicology, is there anything we need to answer now that wasn't answered back in the day? And so, no, we don't have those environmentally persistent things. And then the thing that makes a chemical bioaccumulate, which was why there was the problem with hawks and eagles and their eggs, is because a top predator ends up getting the most of something that bioaccumulates in the food system. Well, the chemical properties that make something bioaccumulate are actually fairly easy to understand. And so it's pretty easy for a regulatory agency to look at the data and say, okay, this is or isn't something that would bioaccumulate.
And I imagine there's some overlap, probably not perfect, but some between how things might bioaccumulate in the soils and how they might within complex organisms.
Yeah. Well, and there's multiple mechanisms involved in the breakdown of a chemical. Sunlight is actually pretty good at breaking down a lot of chemicals. There's the metabolism by the plant itself. There's the metabolism by microbes in the plant, on the plant, in the soil. You know, there's a lot going on out there that breaks things down. But sort of the ironic part is, I would say the one chemical with a long-term persistence issue that's still out there are those things based on copper. Because copper, you know, yes, it is a natural element, and we actually need a little bit of copper, you know, as a component of some of our enzymes and everything. But there can definitely be too much copper, and copper isn't going to break down into something else. It's going to be there. And for many decades, the only fungicides that people knew about were copper compounds. And in places like Europe, where they were used extensively in vineyards, it actually built up to toxic levels to the plants in this vineyard soils. There are ways that copper can get sort of immobilized and not be an issue, but it's almost as if the one category that's out there that still has a long-term persistence problem is ironically a mainstay of organic agriculture.
And not part of the testing and reporting process.
Yeah, exactly.
Do you know if it's just the nutritional overabundance of copper itself, or it's some of the copper compounds and their toxicology that's relevant? Or
I'm not the expert on that. I think it is certain forms of copper. So there are forms of copper that probably are not toxic. The same thing is true with arsenic, for instance.
Sure.
You know, there are sort of organic complex things that have arsenic in it that aren't dangerous, whereas arsenic on its own obviously is really, really dangerous.
Sure. Inorganic arsenic in drinking water versus organic arsenic as found in rice or something.
Yeah.
Quite different in how they work through the body.
Yeah, they are. And I mean, and I think it would be great to actually even have less in the rice. And there are people working on, you know, how could you do that? But, you know, arsenic is something that's out there in certain soils just naturally. There was a time in the bad old days when arsenic chemicals were pesticides, but we haven't been in that mode for 40 years.
Well, they were also part of hot crossed buns back in the day.
Great.
That's where that yellow sheen came from.
Well, they made a great, was it a movie, Arsenic and Old Lace? So,
That's right. Along those lines, this wasn't a topic we had slated, but any comments on just glyphosate and its relative toxicity compared to other pesticides that it might displace?
yeah, well, and that's a tricky one because that has this super intense sort of political focus because it's such a prominent
Right.
material and it's something that farmers really like and need. And this goes back to its discovery like in 1972. In fact, I was just talking with some of the people who were involved in finding it in the earliest days.
Oh, wow.
And I hope to sometime do a podcast on that history because when people hear about it, say, oh, it's the most widely used herbicide. And so it seems like nobody asked, well, why is that true? Um, it's true because it actually was really helpful to farmers in ways that other things haven't been. But it's probably one of the most experimentally tested molecules that's out there. And if you go around the world to the agencies, whether they're in Europe or Australia or New Zealand or Japan, that have the job of deciding what is and isn't dangerous, what is and isn't a likely carcinogen, they all would say, no, it's not. It's fine, including our EPA. And that was long before the sort of politicization of that whole thing in recent years. But there's this one group called the IARC,
Hmm.
and
European?
it's within the World Health Organization. And they look at things, they do what's called a hazard assessment. They don't actually assess risk. They don't ever identify something and say, we know that this, is really going to cause cancer. They just say, well, there's a possibility. So the things that they have looked at over the years, they would list coffee, they would list fried food, they would list working night shifts. I mean, it's almost like nothing they ever look at, they don't say, well, it could cause cancer. They kind of say that about everything that makes it into their committee process. But there's a blogger from Europe called The Riskmonger, and he's done a great job of sort of describing and documenting the politics behind that finding by IARC about glyphosate. And the leader of the committee was somebody who worked for what I would consider, one of your less reputable environmental groups. But he didn't disclose that. When they did their review of the data, even though there was somebody from the American government who knew that the largest epidemiological study on farm worker chemical exposure and cancer had been completed and said that glyphosate was not a problem, he knew that data was about to be published, that had followed like 70,000 people over a long, long time. And but their rules are that unless it's published, they can't consider it.
Oh, wow.
But he has since, been interviewed and said, well, yeah, if we had been allowed to look at that study, we totally would have come up with a different conclusion.
Huh.
But instead of, we kind of had this flawed committee process and that was manipulated, and actually the people manipulating it were being funded by the law firms that now stand to cash in on all the lawsuits.
Oh, my goodness.
That's the actual story. But what you see out there is, we know it causes cancer. And no reputable regulatory agency around the world would agree with that.
So does this group ever put out redactions or updates or?
Not really. And and even within the World Health Organization politics, they are not considered very legit. And again, I would refer people to this guy called The Riskmonger, and also the Genetic Literacy Project has done a lot of good articles sort of drilling down into that history.
I'll pull together some links like this for the show notes. I'll make a note on this real quick here.
Yeah. Well, and I don't think I'd put in any of those because I was focusing on
Sure.
the dirty dozen list.
Right. So, other comments about just our progression. And the data I've seen argues that, if anything, glyphosate allows farmers to use a lower amount of exposure. Oh, I'm sorry. One thing I'd love you to expand upon for listeners is differentiating risk and hazard. I think that those are terms that, to the lay
Yeah.
audience, are quite interchangeable, but in discussions of toxicology are just completely different ideas, and they often get juxtaposed.
No, they are. And I feel like our education system sort of fails us in not teaching us the difference between risk and hazard. But an old friend of mine who's been, involved in the agricultural space a long time gave me what I think is the best analogy, and that's electricity. So you think about it, electricity is something that's pretty important to our lives, right?
Sure.
Can you imagine life without electricity? We certainly wouldn't be having this conversation, right?
Right.
But the truth is that depending on the form it's in, and electricity can be extremely hazardous.
Hmm.
Uh, that's why we do a whole bunch of things to prevent ourselves from being exposed to it. So we have electricity, which is very, very hazardous, but we mitigate the risk by controlling the exposure. And that's kind of the fundamental difference between hazard, which means, it could kill you, like electricity, and actual risk, which means your risk is really very low.
So we have
unless you kind of are a do-it-yourselfer and try to do your own wiring in your house. That's where people actually get through the normal protections. Because think about it, we have child-proof plugs, we have GFI switches on any outlets that are close to water. We put high voltage lines way up on towers so that hopefully people don't ever touch them. But that's all just mitigation factors to say the risk is low. And so the same fundamental thing. Oh, and then the other thing that we do is that cell phone that you're perfectly comfortable sticking in your pocket. Well, that's using electricity, but it's using a form of electricity that can almost not hurt you. Very low voltage direct current is a form of electricity that's not dangerous. And so the same two principles work with chemicals. If it's actually a hazardous chemical, you protect yourself by trying to not be exposed to it, whether that's you wear gloves, if you're handling it directly, or a respirator, or this whole thing about setting the rules so that by the time it's something you're eating, you're not being exposed to enough to make any difference. Those are all about exposure. But then the other side is low hazard materials. And really today, a lot of the things we use as pesticides aren't hazardous at almost any dose, And when people can find something that actually works that's low hazard, that's great.
Well, it ends up being more cost effective as well. They can use less of that in application.
Yes and no. That all depends on the compound. Yeah.
Okay. Yeah, that would be a separate variable. That makes sense.
Yeah. I mean, most of the synthetic chemicals that would be used today as pesticides are used at very, very low concentrations. I mean, the product is put out at maybe a few ounces to the acre. Some of those old things like the copper sulfate or the like sulfur dust, which is organic approved fungicide, that's put out at 10 to 12 pounds an acre.
Oh, wow.
Many times a season. Yeah.
So for the average consumer, just wondering about their produce, in the big scheme of things, not a clear distinction on organic versus commercial. And also, I looked over the reports that you had and others. It seems that there's really not much to worry about. That there's a pretty good job in terms of tracking these things and looking at the amounts, and exposures that we have are probably more relevant to what's already in the plant than what goes on top of it.
Yeah, I definitely say so. And again, fortunately, even those plant-made things that we're getting at much, much, much higher concentrations. Here's one. Something like eggplant
Mm-hmm.
or peppers or tomatoes, they have some nicotine in them. Okay, we know about nicotine. We know that nicotine isn't great stuff. And if you ate some gigantic amount of, not that gigantic, but if you were to eat 20 pounds of eggplant, you could get yourself a toxic dose of nicotine, but you don't normally have to worry about that. Actually, the only chemicals that I, as an agricultural scientist, worry about in my food are a group that almost nobody ever talks about. And you have a group like Environmental Working Group that says what they're all about is protecting us from toxins. They don't talk about this, essentially. And it's a thing called a mycotoxin.
Mm-hmm.
And usually, not always, but usually in relation to some crop that gets damaged by an insect, and then certain fungi can grow in that injury, and those fungi make chemicals we call mycotoxins. And those are things you actually really don't want in your food supply. We are very, very fortunate in that the farmers use a whole bunch of integrated methods to pretty much make sure that never happens within our food supply. The one place that you actually end up having to worry about it tends to be with organic imports. So, for instance, a lot of organic corn is imported to Canada
Mm-hmm.
because Canadian corn growers, don't think that what they're paid to grow corn organic is worth it, because it isn't. And so it gets imported from other parts of the world. And some of those places are not doing this good job of keeping this toxin out of the food supply.
Wow.
And finally, Health Canada, I believe it is, set up a program that they test every load of organic corn that's imported for aflatoxin, which is probably just about the nastiest carcinogen and acute toxin that we know about. And because when they would randomly test, they would keep finding it. Now, that's corn that's going to be fed to animals, but aflatoxin can come through in the milk.
Oh, wow.
Yeah. So again, it's one of those, it's a tricky one for an industry because, if you're being protected and you're actually safe, it's kind of like, why even bring it up? Why get people potentially scared about something that isn't a problem? But to me, I think it's something that's worth people actually knowing about, just to get some perspective on things.
So conceivably, organic milk that was Canadian in origin could have more of a risk for having that, or?
Yeah, that would be true. The one that I would worry about more than anything would be imported almonds.
Oh, okay.
Because almonds can be contaminated with this, and our California industry does an amazing job. And there's a whole bunch of things that are involved in, controlling the insect that causes the damage. They use a biocontrol fungus that can maybe, sort of compete with and displace the bad guy fungus in terms of infecting any insect damage that does happen. And then finally, in the final process, and I think this happens with lots of peanuts in the US as well, the nuts, the individual shelled nuts, go down a conveyor line. Now, we're talking about nuts that are being handled in the millions of pounds, right?
Mm-hmm.
But they go individually down a conveyor belt, and they shine a certain wavelength of light on it. And if they detect an infrared reflection of the light, that comes out from that suggests that the fungus might be there. And so a little puff of air knocks that nut off of them. Yeah.
That's incredible.
Yeah. My wife's science class once, we arranged for a tour up in the almond industry, and they actually got to see that in process.
So each individual almond is inspected in some automated way.
Yeah. And so, and for the almond industry, it's kind of a mixed bag for them. It's like, well, do you talk about this? Because potentially somebody, especially they know what kind of groups are out there, like the people who make the dirty dozen list. Somebody could take this information and make it look really bad and scare people half to death.
Yeah.
But in this case, if you get your imported organic almond from Turkey or Uzbekistan, you're at way higher risk.
Hmm. Is that relevant? I've heard of other past sources of possible aflatoxin, peanuts, peanut butter. There's been some talk about coffee as of late. I don't think those are significant issues. Would you say otherwise, or?
Again, as long as you're within our system in general, I think with coffee, it has more to do usually with some of the processing steps, the very elaborate things that go on to go from, the coffee cherry all the way through to your roasted nut. And I think I think aflatoxin can be there. There are some other toxins that might be more likely, like if it's too moist during the time that it's sort of what they call fermenting, kind of trying to get rid of the slimy stuff that comes from the cherry part. Apple juice can get some contaminants in it, usually not aflatoxin. Aflatoxin can definitely be in corn. Mostly in field corn. It's not going to be an issue in sweet corn because it really wouldn't develop until the corn is mature. Basically, sweet corn, we're eating immature corn seeds, right?
Got it.
But there are other things that can be in corn. Another one of these toxins is called fumonisn, and it's actually well documented that the insect-resistant biotech GMO corn that's out there actually has much lower levels of fumonisn as a potential contaminant. Yeah.
That's pretty wild. So aflatoxin in some contexts, in some imported foods could have some relevance, but.
Well, and what's really sad is that within a lot of the developing world, like say in sub-Saharan Africa, maize or corn is a really important food crop. Here it's mostly, an animal feed crop. There it's a very important food crop. Ground nuts, which we would call peanuts, is another very important food crop. And they can definitely be contaminated, and the contamination can get worse because their storage conditions aren't as rigorous. And the fungus can develop further within storage. And there are a lot of people, you can look it up. Probably one of the leading causes of death and leading causes of cancer in the world is aflatoxin, but that's almost all unfortunate people in the developing world.
Wow. And that's mostly liver cancer, right?
Yes, exactly. Yeah. So,
but not the things we're told to be afraid of.
Yeah, no. And it's interesting because I think in that case, there's no big company to blame unless you want to blame Mother Nature Incorporated.
That makes sense. There's no exciting scapegoat.
Yeah. And how do you use it for fundraising? So, yeah. But, I think the really good news is that we enjoy this relatively affordable, diverse, safe food supply, and yet we somehow find ways to turn it into an issue of stress when it could be about enjoyment.
This has been great. Any points that you would hope to cover along this discussion that we didn't get to, I didn't ask about, or?
No, I don't think so. In fact, we got into, the whole mycotoxin thing, which I didn't even think we necessarily would. But yeah, it's like just, I guess the takeaway is don't just automatically jump to the conclusion that if somebody's telling you to be afraid, that you necessarily should be afraid. Like the old saying goes, you can't believe everything you read on the internet.
And in the big scheme of things, produce is good. We've got a good produce supply, especially that from the U.S. Yeah.
Yeah. And really also from our import sources. So within that USDA testing program, they also include a lot of imported food. And basically the same story is true with that, maybe slightly higher levels, all still within the tolerance range. Because the truth is, a lot of the produce that we import during the off season, it's actually being handled by the same, what are called grower shippers. They're not necessarily the farmer, but they're the people who would sort of gather the stuff from the farmers, get it, ready for market and everything, and bring it to the market. And so the same companies are doing that in many cases, whether it was a table grape grown in Chile or in Mexico or in the US.
And I saw with some of those reports about just exposure and thresholds that they're pretty much lumped together. So if there was one thing that was, still safe, but an outlier, that would still create the report for that whole food category, such as grapes or something.
Yeah. And the USDA isn't the only one that does testing. California does a lot of its own testing. And it's, I haven't heard of anybody who tries to utilize that in actually either good or bad ways. And actually the only things that they tend to find that are actually problems are sometimes kind of exotic things. Like it's some kind of cactus based, traditional Mexican vegetable or fruit.
Nopal? Nopal?
Maybe. Yeah. Don't quote me on that because I don't want to scare people about Nopal, but they have had occasions where they tested that and they found something, or there was some sort of it was a root crop from China, and they had found things there. And in the case of the California thing, it's not just a survey. They're using that as their enforcement thing. And so on their website, you could actually find everything that they had an enforcement issue on. And as you look through it, it's usually some kind of exotic imported thing.
Huh. So those that wish to see more of your work, popagriculture.com, best site?
Yeah, that's the site for my podcast that I've been doing for about 1.5 years now.
That's great. And you'll have one coming up soon on glyphosate and all things GMO, you said, huh?
Well, that one's in process. Actually, I think the most recent one is, this is the 50th anniversary of Woodstock, right?
Okay, that's right.
Yeah, and the famous song that was made famous by Crosby, Stills, and Nash, called Woodstock, was actually written by the Canadian artist Joni Mitchell.
Okay.
Anyway, if you remember that song, it ends with the line, "And we've got to get ourselves back to the garden." And I use that as a launching off point to talk about why gardening is a really great idea. Not because you don't have good access to food, but it just gives you an appreciation, and it's fun. It's therapeutic.
Yeah. Yeah. Healthy things psychologically, great way to interact with the natural world. And
I think one of the best things too is a way to kind of give children a sense of what is food and where does it come from, because otherwise most kids will never see a farm. And it was also an excuse to put in a picture of my granddaughter. I'm always looking for that. When she picked the first apple she ever picked off a tree in my backyard. So
you got some apple trees?
Yeah. Yeah, which is actually, I lived in the San Diego area. It's not really a great apple growing area, but what the heck, we got a few apples off of it.
I grew up in northern Minnesota, and we were a farm family. We had a large garden where a lot of our food came from. We collect wild berries all throughout the season and can things, throughout the later part of the year. And Grandpa Christensen was famous for his sweet corn. They would have a corn feed at the township hall, and they would wait till Grandpa said it was time, and pretty much everyone came from miles around for the corn feed.
Yeah. Oh, I know. I would agree with that. And I talk about how, see, I didn't have that farming background, but I had a grandfather who was World War I vet that took the whole victory gardening thing really seriously afterwards. Yeah. And so I grew up helping him in his garden. And I think people And if they can't grow a garden, take your kids on an agritourism thing, give them some way to understand where food comes from.
That's a great idea. Well, this has been wonderful. Super appreciate your time. And yeah, we'll hope that people will look further at your work and stay tuned for that podcast. So thanks again, Steve. And we'll talk sometime soon.
Well, thanks for the chance to talk. That's been great.
Hey, Dr. Christensen here. Thanks so much for joining me for another episode. Is there a topic you'd like me to cover? I'd love to hear from you. Just go to Dr. Alan Christensen on Facebook or Instagram, write your question, and use the hashtag #MedicalMyths. Did you find this show helpful? If so, please take a minute and leave us a rating on iTunes so that others can know. Thanks much, and I'll be back with you real soon. Bye-bye.